First off, good afternoon, and thank you for the invitation to present here today. My name is Dustin Pendell. I'm a professor, an agricultural economist here at Kansas State University in Manhattan, Kansas. And what we're going to talk about here this afternoon is we're going to look at the cost of disease, but we're going to look at it through the lens of different people, right? So different perspectives. So just real quick, we think about the food supply chain. I like to visually see things. And so we think about on your far left, you got your farm or your ranch, maybe where the animals or crops are being raised. It gets transported to maybe the processing slaughter facility. It gets processed, packaged, transported to the market, which then goes to your restaurants, or maybe it goes to your home where you can consume it. It could be put on a boat, and then it could be, exported to a different country. So thinking about this supply chain, again, in real life, obviously, it's a lot more complex than this. And we think about all the costs associated with all these different, I'm going to call them actors or economic agents, the different sectors. So that's what we want to talk about. So what you're looking at now is just a table looking at defining different types of costs or different types of losses from an animal health event. Specifically, this was related to a highly pathogenic avian influenza example, but we can just think in general terms from an animal disease perspective. And so first, you can see highlighted in red there at the top, it says something called a direct loss. So direct loss would be if a disease comes through and the animals, they die, or maybe they're cold or depopulated for some reason. So it's a loss of the livestock or outputs, such as eggs. Indirect losses, this would be, when we think about indirect loss, when we have a disease outbreak, maybe it's not directly related to the disease, but when we're transporting the animals from the farm to the processing facility, that transportation, there'll be losses there. If there's no animals that go into the processing plant, well, the processing would lose as well. Processors wouldn't have to pay taxes because they're not processing animals. So there's reduced tourism. An example here was in 2001 in the UK, there's a large FMD outbreak, foot and mouth disease outbreak. And, after it was all said and done, they estimated the impacts to be, in the billions, like in the, 15 to 20 billion pounds. And they attributed more than 50% of those losses was because of reduced tourism, right? You quarantine areas, people can't go visit those rural areas. They're not spending their money on food, lodging, etc. And so indirect losses can be pretty big, substantial. Next, talking about ex post costs. So these are going to be costs that are happening while the outbreak is happening or maybe after the fact. So think about cleanup costs. You got to disinfect and clean up a barn. If you got to buy certain personal protective equipment, maybe you got to buy equipment or rent equipment so you can dig holes so you can bury animals. You got to hire additional labor. You got to feed that labor. You got to lodge that labor. And so those would be what we refer to as an ex post cost. Market impacts. Market impacts are probably going to be, from an economic standpoint, the contributor to your disease burdens. And when we talk about market impacts, what we're talking about is changes in commodity prices. So we think, as an economist, it's supply and demand. And so when we start thinking about supply and demand, if we remove animals, we're reducing supply. Well, that has a change in commodity prices. And so we think about losing revenue for your producers. Maybe we have to pay more money as a consumer for the product. And so market impacts, that's what we're talking about there. And then finally, you got something we call ex ante costs. And ex ante costs will be something that happens beforehand, before the outbreak. So we're stockpiling vaccines in case of an outbreak. We're stockpiling personal protective equipment in case of an outbreak. We're investing in biosecurity, surveillance before the outbreak. And so those will be ex ante costs. And now what I want to do is I want to go through just a case study that we did here in the United States, talking about some of these different kinds of costs. And then we'll talk about another case study and we'll point out a few differences, thinking about some other kinds of costs. So we've already actually heard a couple speakers, I believe it was Andrew and Eric, talked about risk assessment. Well, I was involved with a risk assessment a while back, looking at a site-specific risk assessment, and this was for Department of Homeland Security. They were looking to build what we call the National Bio and Agri Defense Facility, which is actually currently being built here in Manhattan, Kansas. And this new facility is it's a disease laboratory where we're going to study, not we, but they will study the most highly contagious animal diseases at this facility that's being built here in Manhattan, Kansas. And so part of it, to get the funding to finish the drawings for the building, the Congress, before they released the funds, required a site-specific risk assessment, which was evaluated by the National Research Council. But I'm not going to spend a lot of time here, but just note that there was some origins for the disease could escape. And those origins could escape various pathways. There's probabilities associated with it for these risk calculations that are fed into this, what we call fate transport model. So you're talking about a plume model, how the disease might spread. And then from there, maybe it gets into the animals, the livestock, and then they spread it through epidemiology modeling. The epidemiologists will then give us the output, us, the economists, to look at the economic consequences. And that's really what I want to focus on today, is just this economic consequences. So when we did this economic assessment of a release of a foot and mouth disease virus from this National Bio Agri Defense Facility located, which is being built right now in Manhattan, Kansas, which is that red dot, we specifically just focused on kind of the Midwest, the cattle feeding region here in the United States. And specifically, what I'm going to show you next is we're just going to talk about one possible origin of escape, and then called liquid waste. So we accidentally dumped you dumped the FMD virus down the wrong drain. It got into the system, the water system. Somehow it escaped, got into a farm nearby, and then it spread that way. We're also taking a look, incorporating risk and uncertainty into this, both from an epidemiology model and also from an economic framework. And that's what this second column is. And so if you want to think about it, if you look at just each row, just think of that as kind of not really a different scenario, but for this purposes, we'll just think of it as a different scenario. But then you go to your two columns to your right of that, what we're calling the direct losses in our market impacts. So what's called producer returns to capital, and then also consumer surplus. So your producer returns, think of that as your profit, right? So you got revenue minus expenses. And that's going to be producers. And we're talking producers. We're combining all producers together. Okay, so we got beef producers, cattle producers, we got meat packers, you got crop producers, swine, lamb, poultry, eggs, everything. Consumer surplus, what that is, as an economist, we tend to measure how well off people are to changes in events such as an animal disease. So if you go to the grocery store and you buy a product and you're willing to pay this much for the product today, but then you come back tomorrow and let's say it's higher, well, you're worse off because you got to spend more money to buy that product. And so we think of that as what we call consumer welfare, consumer surplus. But those are direct losses and market impacts. So we have changes in prices and quantities, and then we estimate from those changes in prices and quantities what those impacts are going to be. Next, and so in just some examples, some range for these different scenarios, you can look from anywhere from $0 of an impact from a disease outbreak to about $65 billion. Next, we got our ex post and ex ante costs. And so these are thinking about from a government standpoint. Specifically, we can break it down into indemnity payments. So if the government comes onto your farm and has to depopulate your herd or flock, they're going to probably compensate you for that. And so that's what we refer to as an indemnity cost. Your non-indemnification would be surveillance, biosecurity, vaccinations, disinfecting, cleaning, etc. And so if you look, again, they range anywhere from about $0 to about $15 from a government standpoint. And then finally, our indirect losses, so tourism, local taxes, etc., on our what we're call here regional non-ag impacts, range from anywhere from $0 to about $4 billion for a total impact of this particular event or particular scenario with if a foot and mouth disease virus was released from this facility and it did spread, total losses can range anywhere from 0 to that 140 billion with a B dollars. And so again, pretty significant impacts. And you can see all the different players that were involved. Now what I want to do is I want to focus just on this one single number. So this one single number, it's $56.8 billion. I want to break that out into more detail, because what we're doing is we're aggregating a whole bunch of different kinds of producers into this single number. Not only are we doing that, but we're also aggregating this across time. And so when we have a disease outbreak, the disease outbreaks last for anywhere from a few days, maybe 30 days, to about 460 days in length in this simulated scenario. Well, we know the economic impacts, it takes a lot longer to get international trade resumed and to get back to some long-run equilibrium. And so this number, actually, this 56.8 billion, is a whole bunch of different types of producers across a 10-year span. And so if we take a look at it here in this figure, you've got your time across your x-axis. So, and these are quarters, so 90 days. And then you've got your dollars, your losses in, or gains, I guess, in your vertical axis. And so just to point out a couple things, right when we have the outbreak happens, this is an outbreak that lasts about 460 days or 5 quarters. You'll notice this purple line, which are your crop producers, they tend to lose, and they lose a lot over time. And it's about 20 quarters before they get back to kind of this break even, this long run equilibrium. Whereas if you're the black line, you're a beef cattle producer, right when the outbreak is happening, prices fall. You're worse off, you lose your producer returns. But then as the outbreak goes on, you'll notice it's in the positive territory. And so they're actually winners in this case. And so you can see the two things I wanted to point out here is everybody's being impacted a little differently by species, but we're also, nothing happens today, tomorrow, it's across time. And so the returns are changing across time. I just want to point out one other study. So this was a very specific study to the US, and different players along the supply chain were being impacted. A different study by Daniel Mason Cruz and some colleagues, they looked at the global economic consequences of a major ASF, African swine fever outbreak in China. And yes, they did some economic modeling, and you can see how they looked at changes in world prices for selected commodities. Price of pork went down. But the one I want to point out specifically is maize or corn. You'll notice maize or corn, the price falls. Well, why is that? Well, the main feedstuff for swine is corn. And if there's less swine, there's going to be less of a demand for maize, and then less demand for maize, that means there's going to be prices are going to fall on the globally. So why is that important? Well, one thing we never talked about in that previous foot and mouth disease study in the US is what's nice about this study is they go to the next step and they say, okay, we have this animal disease, we have the economic impacts. Well, then they go and say, well, what happens to the calorie availability globally by country, and then the risk of hunger? And so you can see the two things I want to point out here is you reduce the protein, reduce pork, you have fewer calorie availability, and you also increase the risk of hunger in most countries. So look, China, Southeast Asia, Australia, Europe. However, there is a spot that you can see here in yellow, Sub-Saharan Africa, where the risk of hunger actually goes down with the disease outbreak. And you might be asking yourself, why? Well, the authors argue that the dietary staple is maize or corn in this region. And if you saw in the previous slide, corn prices go down. And so the thing I wanted to point out here is there are actually winners in a disease outbreak. There's a lot of producers, a lot of people, there are losers from an economic standpoint, but there are some people who are better off because of an animal disease outbreak. I've got 2 more quick points I want to make, and then we'll wrap this up. First one is we haven't really talked about the human health side or the zoonotic component to diseases. We've only mostly focused on the animal side with African swine fever and foot and mouth disease. If we switch gears and we start incorporating the human health component into it, that's when the costs go up significantly. And so when we start thinking about disease outbreaks that maybe have a human component, such as high path AI, BSE, SARS, COVID-19, when we start talking about humans going to the hospital, when we start talking about the productivity losses, people not being able to work, when we start talking about human deaths, that's when our costs are going to increase significantly. So that's something to think about when we think about, can we control or can we even eradicate diseases through the biotechnology in food production? And then the final thing I want to point out is Sarah in the last talk started to talk about this idea of consumers. And I think we're actually going to see a couple more presentations here later this afternoon that talks about general public, but there's a whole set of economic literature and it's growing by the day that looks at the economics of willingness to buy, willingness to pay for kind of bioengineering technology in food production. And what I want to leave you with is there's costs associated with that as well. Although we might be able to use some bioengineering technologies that can help reduce, maybe even eradicate animal diseases like African swine fever, and the science can tell us if we can do that. But we cannot forget about the consumer. We cannot forget about the society because they're going to tell us if we should do it. And with that, I'm going to conclude this presentation and I will, open up to questions if we have time. Thank you.